Okay, now we're going to graph inequalities. Okay, so instead of, when we graph a line that's really a collection of points, a whole bunch of points on a line, when we graph inequalities, it's going to look like even more than that. It's going to be a line and everything shaded on one side, a collection of x, y coordinates, not just on a line, but everything either greater than or less than that. Okay, so here's the process for this. It's not really too much more work than graphing a line, because that's really what we're going to do first. Okay, so the first thing we're going to do is graph the line. Okay, so you notice there's an inequality there. This reads y is greater than negative 2x minus 3. So what we want to do is first graph the line y equals negative 2x minus 3. Okay? Now, if you'll notice the difference between 1 and 2, 1 there's a greater than sign only, and in number 2 there's a less than or equal to sign. The difference really being this bar underneath. Okay? So basically for number 2, this 3x minus 4 equals 12, that's a line. That'll be included in this inequality. For number 1, y equals negative 2x minus 3, this line isn't actually included. It just says everything greater than that. Okay, so anytime we see just the greater than or less than symbol without the equal to bar underneath, we'll draw a dotted line to indicate that line's not included. Okay, so graph the line negative 2x minus 3 using a dotted line because the line's not actually included. It's just everything that's either greater than, everything greater than that. Okay, so let's see if that makes sense. Let's go down here. We started negative 3. Remember how to do this? We just did these. And the slope of this line is negative 2, right? So that means I go over 1 and then down 2. Like always, we're assigning our negative up top. So I go over 1, down 2. So here is my second point. Okay, so now I'm going to have to draw a dotted line through this, which isn't going to be easy. Okay, so let's see. Let me do my best. How about this? So we want a dotted line through these 2 points. Okay, not the best line, but you get the idea. Alright, so not a solid line, a dotted line again, because this isn't included. And then we're going to shade on one side. So here's how we do that. We need to pick a test point. Okay, so what we just did was basically the same as what we did before, only the line's dotted. And now we pick a test point. A test point on either side of this line. Okay? And we plug it into my inequality. So the test point, I can pick any test point, anything I want on either side of this dotted line. Here's the point 1, 0. Here's the point right here would be 2, 2. Any of those on either side is okay. I'm going to pick 0, 0. Why do I pick 0, 0? Because that's the easiest point. It's less work when I plug it in. Okay, so I plug it into the inequality. So let's go back to this original inequality. I plug in 0 for y, 0 for x, and I see what happens. I see if I get a true statement. Okay, so negative 2 times 0 is 0, so that's gone. And look what I'm left with. 0 is greater than negative 3. Is that true? Well, it is, right? 0 is greater than negative 3. So I know that this point is part of my solution set. Okay, and that also means that everything else around that point has to be part of my solution set. So basically what I can do is I shade everything on this side of the dotted line. All these points over here are solutions to that original inequality. Okay, anything on it, you can test any one of these points, it's going to work out. Okay, and that's what my answer looks like. It's a little messy, but that's the best I can do. Okay? Step 1, graph the line. Step 2, pick a test point. If you get a true statement, graph everything on that side. If you get a false statement, what we'll do is graph everything on the other side. Okay? Let's try another one. So here's another, what we're going to do again is graph the line first. 3x minus 4y equals 12. 3x minus 4y equals 12. And then we'll deal with the inequality next. Okay, so if you remember, we did these by, this isn't mx plus b, so we did these by drawing this chart. x and y, and graph them by zeros. Okay, so we're going to graph again the line, and it'll be a solid line because of this underscore. The line's included in the inequality. If I plug in 0 for x, what do I get for y? Three times 0 is 0, that's gone. Divide both sides by -4, and you should get -3, right? So y would be -3. That's this point right here, 0, -3. And then do the same thing over for y. Plug in the 0 for y, that is. 3x minus 4 times 0 equals 12. 4 times 0, of course, is 0. That's gone. And I'm left with 3x equals 12. Right? 3 times some number is 12. That number should be 4. Right? Divide both sides by 3, and you get x to be 4. And that's how we handled those ones that were in standard form, if you remember that. 1, 2, 3, 4. It was right here. And then I can draw a solid line because the line is included in the inequality. So I draw a solid line through these 2 points. Okay, and now I just have to decide what side to graph. Do I graph on the left side or do I graph on the right side? Again, I'm going to pick the 0, 0 point just because it's easy, right? Pick the intercept. It just makes it easier. If I plug in 0, 0 here, 3 times 0 minus 4 times 0, is that less than or equal to 12? I'm asking myself, is that less than or equal to 12? Well, yeah, everything over here is 0. Right, so again, I end up with a true statement. 0 is less than or equal to 12. So I know that this point is part of my solution set, which means everything else on that side is also part of my solution set. So I graph everything on this side. Okay? And that's it. Alright, so it's basically just a couple more steps than graphing the line. Okay, let's do a couple more special cases. Okay, so you'll recognize these. It's x is greater than 4. So basically what we have to do is graph the line x equals 4, right? So I want to graph this line first, x equals 4, and then decide what side to shade. So x equals 4, so I recognize that it's the inequality is x greater than 4. So when I graph the line x equals 4, I have to make it a dotted line, right? Dotted line at x equals 4. So that would be right here. Because the lines, it is not included, it's just everything greater than 4. Now this thing I don't really need a test point for it because I know where greater than is for x. It's to the right. Right? Here's x equals 1, 2, 3, 4, and then 5, 6, and so on. So my solution set is all the values going this way. Right? So this is where I shade. That's how I graph x is greater than 4. Alright, now the y is less than or equal to -1. So again, I want to graph the line y equals -1. And I'm going to use a solid line because the line is included in the solution set, right, with that underscore. And hopefully remember how to do that. Y equals -1 is this line right here. Right? And then I'm going to graph everything less than that, right? So less than -1 for y less than, that's below, right? That's everything underneath. So I simply shade everything down here. All those values, y values, are solutions. Regardless of the x value, those are all solutions to that inequality. Okay? It's only a couple examples, so you really got to read through your book, look at the examples, and practice.